You ever hit refresh on a web page and bam, it suddenly works? Or maybe a payment fails, but you try it again a second later and it goes through just fine. Well, that's often thanks to this hidden mechanism called a retry. It's kind of like the unsung hero of the internet. But, and this is a big but, as we're going to see, this hero, it's got a dark side, one that can bring entire systems crashing down.
So you might be asking, why do we even need retries to begin with? Well, to get that, we have to look at this huge shift in how we build software. See, back in the day, we lived in what you'd call a monolithic world. The whole application lived in one place, like a single box. Any calls between different parts of the program, they were internal, super fast, and pretty much always worked. But today is a whole different ballgame. Our apps are distributed systems. All these different pieces are spread out and have to talk to each other over this big, messy, unpredictable thing called the network. And yeah, that's where the trouble really starts.
And this new reality, it brings us face to face with a famously wrong assumption. See, decades ago, some really smart people put together a list called the fallacies of distributed computing. These are the things you might think are true about these systems, but are absolutely not. And right at the very top, number one on the list, was this simple, mistaken belief. The network is reliable.
Yeah, except the hard truth is, the network is anything but reliable. I mean, think about it. A request can fail just because of a tiny, momentary hiccup. A dropped packet here, a timed-out connection there. It doesn't mean the services themselves are broken. Not at all. It's just, the chaos of the internet.
So, with all that unreliability, you have to start thinking defensively, right? So, let's say a request fails. You're pretty sure it's just one of those network blips, not a real serious error. What's the most natural, most intuitive thing in the world to do? Yeah, you just try it again.
And that super simple, common sense idea, it actually has a formal name. We call it the retry pattern. It's basically just an automated process where a failed operation is, you guessed it, try it again. The whole goal is to take that temporary network hiccup and just make it vanish, turning what would have been a failure into a success, all without the user even noticing.
Okay, so here's how that little magic trick actually works. Let's say Service A sends a request over to Service B, but oh no, the network drops it, the connection fails. Now instead of just giving up and throwing an error message in your face, the system's retry logic kicks in. It automatically fires off the exact same request again, and this time, it goes through. For the user, it's like nothing ever went wrong. The failure just disappeared.
I mean, on the surface, this seems perfect, right? It's a simple, effective solution. It takes an unreliable system and makes it feel reliable. It's almost like we've beaten that first fallacy of distributed computing. But you knew there was a but coming. As with pretty much everything in these complex systems, there's a catch, and it's a big one.
And here it is, the catch. If you use retries carelessly, or what engineers call indiscriminate retries, it's not just a bad idea. It's like lighting the fuse on a bomb that's sitting right in the middle of your system. The very same tool that's supposed to make everything more reliable can actually become the trigger for a massive, catastrophic, system-wide meltdown.
So, welcome to the dark side of the retry. Because when they're used badly, they don't just fail to fix the problem, they create brand new, much bigger problems. They can amplify slowness across your entire system. They can absolutely drain critical resources. And, worst of all, they can kick off a deadly domino effect we call a cascading failure. And that can bring down the whole show.
All right, let's actually walk through how this disaster can happen. Let's paint a picture. Imagine a really common situation. Just one single service out of hundreds starts to get a little bit slow. Maybe it's just dealing with a lot of traffic. It's not broken, not at all. It's just struggling to keep up.
Okay, so what happens next? Well, all the other services that need to talk to our slow one, they start to notice. Their requests are timing out. And so what does their retry logic do? Exactly what it was told to do. It immediately sends the request again, and then again, and again. So instead of giving that struggling service a little breathing room to recover, the rest of the system starts to just hammer it relentlessly. And this is that cascading failure in action. That flood of retries becomes the final straw. The one service that was just a little slow is now completely overwhelmed by this retry storm, and it crashes, it goes down. And now, every other service that depended on it starts to fail too, setting off this massive chain reaction. The irony is just brutal. The very solution we put in place to handle failure is what caused the total system failure.
So what this really shows us is the true nature of the retry pattern. It's not some simple, easy fix you can just throw at a problem. Nope, it's a really powerful tool, but it's one that forces you to make a fundamental trade-off when you're designing your system.
So what is that trade-off? Let's break it down, because this is the absolute core of it all. You are making a conscious choice. You are intentionally accepting a little bit of slowness, what we call latency, in exchange for a lot more reliability, or what we call availability. You're literally trading a little bit of speed for a much better chance that the whole thing will actually work.
Which leaves us with this final, critical question. Look, the retry pattern is essential. You pretty much can't build modern software without it. But we've seen it's also a weapon that can totally backfire. So the real challenge for any engineer isn't if you should use retries, but how you use them smartly. With strategies that help build systems that can bend without breaking. So the question is, how will you find that right balance? How do you make sure your savior doesn't become your saboteur?